Welcome to WAPI Bytes, learning the Infoblox web API 5 minutes at a time. In today's episode, we'll be talking about how the WAPI allows you to cope with operations that generate large result sets. In the previous episodes, we have dealt with very small sets of objects. However, in a production environment, you could easily have tens of thousands of items that could be returned by, say, a search operation. I have inserted 10 networks in the system from 1034.110/24 to 1034.110/24 with an extensible attribute site set to test to use for this demonstration. Let's first retrieve all of them, passing the extensible attribute we want. As you can see, all the 10 networks have been returned. By default, the amount of results that the WAPI can return is 1000. This is controlled by the _max_results request variable. As you can see from the documentation, the default for this value is in fact set to -1000, which means that for any requests returning up to 1000 objects in its result, it will return them, and if you would have had more than 1000, it would return an error. If the value had simply been 1000, no error would have been returned. The server would have returned you the first 1000 objects matching your search criteria and ignore the rest. Let me now show you what this error would look like. Since we have only 10 networks in our system, let's lower max results to -5, for example, and see what happens. As you can see, the server now returned an error, because the search would have returned 10 networks, but we have specified we wanted at most 5. Using a negative number in max results is useful if you want to make sure you don't mistakenly miss on objects you should have processed. Sometimes, however, you're interested in only a couple or even only one object from your result set. Say you want a network that matches a particular extensible attribute, but you don't really care about any other. In this case, you would be able to increase your query performance by setting max results to a positive value corresponding to what you're looking for. For example, if you just wanted any network matching, you could simply run the search setting max results to 1. As you can see here, we just got one network back without any errors. What would you do though if you had a large result set but your application could not process the full set all at one time because it's too large? This is where being able to page the results would be useful. For example, let's now try to retrieve our 10 networks at most 4 at a time. In order to tell the server we want to page the results, we have to set a few different variables. These are discussed in the documentation of GetRequests here. To execute a paging request, first of all, you should set _paging to 1, then _max_results to the page size you want, which in this case is +4, since when you page you always expect to have more than max results. When paging, you should always specify a positive value for it. Finally, we also need to add _return_as_object set to 1 to tell the server we want our results wrapped in a results object. We have encountered return as object before when we executed object insertions and modifications to return the object reference wrapped in a JSON dictionary for ease of parsing. When applied to search requests, the results object instead wraps the objects that would have been returned in an additional dictionary, which contains paging-related information. In this case, for example, if we execute this request, you can see in our results we got 4 networks in the result fields, as well as a long string contained in next_page_id. This string is the identifier we need to give back to the server to retrieve the next page of results. Note that this will change for every page. To retrieve the second page of results, all we have to do is send a request to the server for a network object with only _page_id set to the value that was returned here. Note it is mandatory for these subsequent requests to be sent to the same object you used when you sent your original request with _paging set to 1. The page ID is guaranteed to be URL safe, so you can just pass it as is without worrying about quoting it. As you can see here, the server once again returned us 4 networks and another next page ID value. The presence of next page ID is how the server lets us know that there are more objects to return, which means that if we now submit another get with this newly returned page ID instead, we will get a result set with no next page ID, signifying that we are done with the search and we have retrieved all the results we asked for. In this case, all the 10 networks, 4 in the first 2 pages, and 2 in the last. It is really important to remember when paging, every request you send to the server is considered independent. This means that if someone inserts an object matching your query while you're paging, Your result set might not contain this new value depending on where in the result set you happen to be when this happened. This concludes today's WAPI Bytes episode. Till next time.